I've got is some example questions for you. So what we're going to do is have a look at this. I'll give you a minute, roughly. Go a bit quicker than that. This one's quite an easy one. It is a LINX 1 question. So it's circle the best answer. So we only want one answer. I'm going to ask someone in a minute. And what you've got is an example of something. It doesn't tell you what it is, but is it a routing table, a bridge table, a MAC table, or a ARP table? An ARP table, it should say. But anyway, is the answer A, B, C, or D? Anyone? Yes, whoever said that, D is the correct answer. I was beginning to think, oh, maybe you're not that technical, but anyway, D is the right answer. So, you know, and the basic idea is, it is an ARP table. That's the sort of thing we want people to understand. There's obviously other questions we could ask on that, etc. And there are other questions on ARP tables to do with static, dynamic entries, etc., etc. But that's an example of a nice, easy question. This is another question that used to be in there. I don't think this question's in there anymore. So this one's circled at apply. Again, I think it's quite an easy question, but the idea is you do need to know what DHCP does. And the answer, and again, I should give you a minute, so I'll give you your advance, so I'll give you about 30 seconds, but the answers could be A, B, C, D, E, or F. It's got to be more than one of them, and the question is, which one is it? So what is it that DHCP does? Hopefully, while I'm talking, you're either on internet relay chat or actually having a look at that and actually working out what's the answer. Does anyone know the answer? It's got to be a brave man that will actually shout out or put the hand up. ACD. ACD. Does anyone disagree with that? Yes, but because we're going by the yeah. Now implementations are interesting. So I've got some example LINX 3 questions which are implementation specific. So although we teach the RSCs, there's no getting away from it. You've also got implementations. However, for example, ACD is the correct answer. I can't see that. I've never seen DHCP build a routing table. Again, if you have, that's where you could write a comment and then we'd have to investigate. Dynamically switching to another level 3 protocol, I've got no idea what that would involve, so that's wrong. And dynamically installing TCP/IP on hosts would be pretty interesting that DHCP already uses it. So anyway, A, C, and D, I think are pretty much okay. Right, LINX 2, we take a step up here, and the questions get a bit harder. It's not that much harder, so hopefully you can see that all clearly. And I'm going to talk a little bit while you read it out, and then I'm going to ask who it is. But the basic idea is LINX Week 2 is all about routing, and more routing. So the idea is you should be able to read a routing table. The fact that that's come from a no, it hasn't come from, it's come from a PC, so it does tell you that in the question. There's a PC routing table, so the question is, what is the answer? So this is an interesting one. Does anyone want to go for the answer? So the idea is, hopefully you've looked at the routing table, and some of those are just totally wrong, and some of them are plausibly wrong, etc. So what's the answer for that one? Yeah, okay, I'll give you a little bit more time. B is true. B is true, yes. B and E, yes, B and E are the correct answers. Yeah, okay. So B and E are the correct answers. Interesting ones are things like that there is a default gateway. There is only one default gateway there. So students should know what a default gateway is. They should know about packets for network 11 won't be dropped because they will go towards the default gateway. Packets for network 10, well, we're attached to network 10, etc. So again, that gives you an example, and yeah, there you go. Right. LINX 3, here's an example LINX 3 question, and I'll let you read it. So that is an output from a Cisco, and the basic idea is it's circle, order, apply again. So circling order apply, you've got A, B, C, D, E, it fell off the page and therefore it's wrapped round to F and G. G is an interesting one, it's wrong. I've got no idea what a state 4 would be, but I'm just giving you time to have a look at that output. So the idea is LINX week 3 is all about BGP. So the question is, you know, things like you should know that eBGP is exterior BGP as opposed to interior BGP. So you should be able to work out whether A is true or false. You should be able to troubleshoot. So we should know that active is good or bad. Always sounds good to me, that one. But it's not, etc. So does anyone have the answer to that particular one? B, D, and E are correct, yes. And A, yes. Which gives you an example, and it's very difficult because I'm not giving you 2 minutes a question. So B, D, and E are correct, but A is also correct. How do we know A is correct? If you look at the very first line, it tells a local AS number. So the idea is, it doesn't really matter whose implementation it is. We should see that the local AS number is 1. We should see the remote AS of all the numbers is AS4, and therefore it must be exterior BGP. Therefore A is actually true. Yeah, okay. You could start writing comments like it's not running because 2 of the neighbours are actually active, which is not good, or idle, which is also not good. Obviously, it depends where it's split second things, but the timers tend to imply that has been going for some time, and therefore it is an issue. Yep. Okay. Anyway, I haven't got long left, so just 2 more questions. I should have picked on individuals, but anyway. Here's another example, LINX 3 question. This is an example of implementation dependency. I'll talk while you just look at this. So the basic thing is we want you, we teach BGP, where you should know how to manipulate paths. LAIT is actually a Cisco specific implementation thing, but it is something that's there. So you could say we should ignore it because it's not in the RFC, but it is something that's there. So in this particular question, it's trying to work out if you're on router 1, how will you get to 172.16? So things you need to know is how do the weights work, how do the meds work, etc., etc. And if they're both in case, which one takes preference? And the answer, this one's an easier one because it's just circled the best answer, but what is the best answer? I always like silence, but I'm sure I heard something out there. Yes, E is the correct answer in this particular one. So again, you might think, oh, the weights, but if we're on router 1, weights are implementation specific. So one thing is, if it's implementation specific, it shouldn't go out on the wire, and therefore router 1 will not know the weight that R2's got or the weight that R3's got. Yeah, okay. So the weight is absolutely irrelevant, and therefore A and B are wrong. The med actually does not influence outgoing traffic at all. Yeah, okay. So again, you might be tricked into thinking it's either the highest, lowest med actually wins, but it affects incoming traffic rather than outgoing traffic. So the answer to that one is none of the above. I've just realised. Yes, would be the one in that particular case, assuming there's nothing else. So in -2 minutes or whatever, many apologies for overrunning. I knew I threw too many in there. Here's actually another example LINX 3 question. Again, it's implementation specific. It could be using local preference and whatever. But what we've got there is a good example. Circle the best answer. Is it A, B, C, D, E, F, or G? I will, given that I've run over time a little bit, E, F, and G are wrong because there's no load sharing going on at all. Router 1 wants to get to 172.16. Which way will it go? Will it go A, B, C, or D? This is actually a bit trickier one, and quite a few people could just fall into a trap of going the wrong way. Is anyone fast enough to get the answer to this one? Sorry? Maybe I should just let you all stew on it, actually. Yes, many apologies. The top 172.16.192.0/19. Sorry, when I was copying these into slides, they got moved along a bit. 192.0/19, middle one 192.0/20, and the last one 172.16.00/16. Basically, I might as well tell you the answer because I've run over time. Many apologies. The answer is... No, the answer is B. Sorry? Yes. Now, yes, so the interesting one on this one is actually the answer is B. Yeah, okay. Why? And the answer is 172.16.192.0/20 is too specific, and the range that we're routing to, which is in the top question, we want to get to 209.224, is out of the range of AS3, what it's advertising. And therefore, we'll actually pick the more specific route, which is the one above, and the highest weight, which is local to the router.